Hello friends, welcome to Math Academy and I am Nur Alam. Now I am very happy with you. Today we are going to learn something new things. So here I am not solving any questions, I am not describing any theory, but in a summary we just go through the important formula of the circles, okay na? And then you will get the PDF of this. You can download of this and you can keep it with you. Before exam you can just revise it and you will be benefited, okay na? In a short time you will get everything. So now you know about the definition of circle. What is it? You know the definition of circle. A circle is a locus of a point which moves in such a way so that its distance from a fixed point is always fixed. This fixed point is called the center of the circle, and the moving point, the distance between the moving point and the center of the circle, is the radius. You know about it. So now if you know the center is a comma b, if you know the center of a circle is a comma b, so center is a and b and the radius is r, then the equation of the circle will be x minus a whole square plus y minus b whole square equal to r square. Okay, now if the center is at origin and the radius is fixed, then you are getting this equation x square plus y square equal to r square. Now this is the standard form for a circle: x square plus y square plus 2gx plus 2f plus c is equal to 0, and here the center is minus g minus f, and you can say that the radius is root over g square f square minus c. A general second degree equation also represents a circle. General second degree equation also represents a circle. So now here you have this general second degree equation: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now this will represent the circle if the coefficient of x square, that is a, and the coefficient of y square, that is b, if both are equal and the h is 0, that means coefficient of xy does not exist. And if this is happened, two cases simultaneously, then you can say that it represents the circle, and the converse is also true. Now consider the second degree, consider the general equation of a circle: x square plus y square plus 2gx plus 2fy plus c, and from here we know that this is nothing but the radius. So if the radius is greater than 0, then what we say that circle with a finite radius you have. If the radius of the circle is 0, then you can say that you are getting the point circle. You are getting the point circle. But if the radius is less than 0, then the center is the real, but the imaginary radius is there, you are getting the imaginary circle. So sometimes you are going to solve the questions. I am describing the point number 8. So now sometime you are suppose going to find out the equation of a circle, and this circle is passing through the vertices of these three lines. Okay, now a triangle is there, and this circle is passing through the triangle of this line, all the vertices of the triangle. So how can we find the vertices of the triangle? Now three lines are there, we take their intersection and you get the vertices. Now if you consider the circle passing through all the three vertices, then you can just put the vertices points on the standard equation and you will get the correct answer for G, F and C. If you don't go for this formula, then you can apply that there are three lines and you have to find the equation of the circle passing through the intersection of these three lines. Then you take these equations L1, L2, L2, L3 and L3, L4, where here L1, L2, then you have L2, L3 multiply with lambda, and then you have mu L3, L4, and which is you consider as 0. So after solving this equation, you compare the coefficient of x square and the coefficient of y square, and you make the coefficient of xy, that is h, should be 0. So in these situations you are getting the value of the lambda and mu, and you put in the equation, you get the equation of the circle. Sometimes ends of the diameters are given. Then the equation that you obtain from this is known as the diametrical equation of the circle. That means if the circle is given and the two end points are given, x1, y1, and here you have x2, y2, then you can easily find x minus x1 multiply with x minus x2 plus y minus y1 multiply with y minus y2. By this you can find the equation of the circle. Okay, now from here also this quadratic expression, when you multiply you get the quadratic expression with the root x1 x2, and when y minus y2 you multiply, you will get the quadratic equation with the roots y1 y2. So this format is also very important. Sometime in the case of the JEE they will said the question like that, you have to use this result directly. Now what about the intercept? Suppose this is a circle and this circle cut the x-axis as these 2 points A and B, then we call this AB is the intercept on the x-axis by the circle. And if it is the circle, it cuts the y-axis at the 2 points C and D, then this length we call it is the intercepted on the y-axis by the circle. So now for the x-intercept, so if you take the x-intercept, this is A, this is B. Now this length of the x-intercept is 2 root over g square minus c. 2 root over, when you take the x-intercept, it will be 2g square minus c. When you take the y-intercept, it will be 2 root over f square minus c. Now if this quantity is greater, that means your x-intercept is positive and you are getting the 2 value where the intersect, your curve intersect. That means the circle intercept. These 2 points will be the different point. If g square equal to c, now you notice that this part become vanish. That means your circle when cut at the 2 points, now in the situation arise when with A and B becomes the equal points. So therefore you can say that in this case the circle have the tangent at that point. It may possible that g square lesser than c. That means you want to say that root over g square minus c is negative. So negative means complex number will come. That means your circle never touches the x-axis or never cut the x-axis. Similarly for the y-axis we have this result. Okay, now intercept on y-axis. Now you are going to calculate some point is there. Now this point is on the circle, inside the circle or outside of the circle. So if you take the point P and whose coordinate is x1 y1 and the circle you are taking S, so now S1 when we put in the equation x1 y1 in the S1, then S1 greater than 0 circle is outside, equal to 0 on the circle, less than 0 means inside the circle. Now next point we are going to describe point number 12. Point number 12 we are going to describe. Okay, now we are going to describe from the point number 12. So here we are discussing about the parametric form. So any point you can take on the circle as x1. If the know the center of the circle is x1 y1, then x1 plus r cos theta y1 plus r sin theta is any point on the circle. This is called the general point on the circle where x1 y1 is the center of the circle, r is the radius. So this is the parametric form that we are discussing here. Okay, now we are going to the next point, that is the tangents. So there are three type of tangents exist here. One is the Cartesian, other is the you can say that parametric form, and next is the general form or slope point form. So three types of circles are there. One is the Cartesian. So in case of a Cartesian, we have one rule. We replace x by x square by x into x1, y square by y into y1, and x is replaced by x plus x1 by 2, and y is replaced by y plus y1 by 2. Now if we replace all the value in x square plus 2hxy, or you have the general equation, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now in this equation, if you replace all these things, x is replaced by x square is replaced by x1, x1, y square replaced by y1, x is replaced by x plus x2, x1 by 2, and y is replaced by y plus y1 by 2. Then you will get this equation here. And now if you consider this x square y square and radius is a square, and any point on the circle is x is equal to x cos theta and y is equal to, you know, that y sin theta. So now you just put here x into x1. x1 is x cos theta. Here we take the radius is a. Okay, now so now our parametric form is, we have the circle x square y square equal to a square, and x is equal to a cos theta and y is equal to a sin theta. So now if you replace here, in this case x into x1 plus y into y1 is equal to a square, and if you replace x1 by a cos theta, y1 by b sin theta, a sin theta, then a get cancelled, and you are getting a cos theta. X cos theta plus y sin theta is equal to a. So this is the parametric form that you are obtained. And if a line y is equal to mx plus c, if this line touches the circle at any point, then what will happen, p will become the r, that is distance is become the r, and you are getting c is equal to plus and minus root over of 1 plus m square. So this c we don't want, we replace this c in the equation of the line, then we have y is equal to mx plus minus root over c into 1 plus c is root over of 1 plus m square. So y is equal to mx plus minus root over 1 plus m square is the slope point form. Here a is the radius of the circle. So y is equal to mx plus minus a root over 1 plus m square is the slope form or the general tangent, we say that this point. Now coming to this point number 14, what will happen from the h ke two tangent can be drawn to the circle. So for the circle, you know that two tangent you can draw from the h and k, okay now, and with slopes m1 and 1 2. Then what will happen, if you in these circles, in this equation, if you replace x is equal to h and y is equal to k, after replacing it, then you are getting the quadratic equation in m, and then what you are getting, the sum of the root will be this one and the product of the root is this one. So this will be the relationship. Now coming to the directed circle, one circle is there, two tangent, one circle is there, from the outside point we draw the two tangent, one circle is there, from the outside point we draw two tangents such that they are at 90 degree. So what we notice that the outer circle, that means their point of intersection of the tangent, this point, it moves such a way so that it will again form a circle. So here the radius of the new circle will be, old circle is having the radius a, it will be root over 2 of a whole square. Okay, now this will be the equation of the directed circle. Now directed circle, in case of the directed circle, from outside when you draw the two tangents, these tangents must be the perpendicular, these tangents must be the perpendicular. Coming to the 14, for 15 is 15 is clear. Coming to the 14, now length of the tangent means what, if you have a circle and from the outside point you draw the one tangent, suppose this point is p and this point is q, then this length from the outside point where the tangent touches the x touches the circle, this length is known as qp length is known as, or pq length is known as length of the tangent. Pq length is known as length of the tangent, and it is nothing but root over of s1. S is equal to x square, suppose you are taking y square minus a square, and s1 is if you are taking the coordinates of the point p, outsider point, then s1 will be the root over s1 will be the length of the tangents. The square of the length of the tangents from the point p is called the power of the point p with respect to the given circle. So now what we have, you know the length of this tangent, you know the length of this tangent, that is p. If you take q, then this length is root over of s1. But if you are taking pq square, which is equal to s1 square, root over of s1 whole square is s1. Now this is known as the power of the point p with respect to the given circle. Here one important property we observe, that suppose this is our point p, this is our point p, and again we are drawing the another line segment like this one, and here is this one, it is our pq, and suppose it is pa pb. So what we notice that in that case, so power of the tangent remains the constant with respect to the circle, that is if you multiply pa by pb, then it will be equal to pt square. Now these results we can't prove it here, but just explain it, that you have this circle and from the outside point you have one tangent, and here this is the secant, it intersects at the 2 points a and b. So now it is p of a, then p of b multiply with p of b is equal to pt square. So p into pb is equal to pt square. So tangent secant property, it is also known as. The power of a point, the power of a point is the square of the length of the tangents. This part we square it. The power of a tangent may be positive, negative, and 0. It is positive when the point p is outside, it is negative when the p is inside, it is on the circle. If the point p is on the circle, then the power of the tangent is 0. Suppose from the outsider point, if you are drawing the two tangents and the tangents are perpendicular to each other, here making 90 degree, and in every if you take the locus of this point, then again you are getting the new circle. This circle is known as the directed circle. So now I am describing here point number 19 also. And now coming to the point number 20. So here we have the some concept like equation of the chord with the given middle point. So you have to find the equation of the chord. You know this middle point coordinate is x1 y1 suppose, and this is A and this point is B. Can we find the equation of the given equation of the chord with the given middle point? The answer is yes. If you take the tangent, the equation, complete equation of the tangent compare with S1, that means value of the curve at the point x1 y1. Achha, now equation of the chord of contact. Chord of contact means what? If you have a circle from the outsider point, if you have a circle from the outsider point, you are taking two tangents, and here now I'm using some color. So these are the tangent, and these two tangents intersect here and here. If you draw this line, this is known as COC, chord of contact. It is known as chord of contact. So when we draw the two tangents from the outsider points, then the points where it touches, that is the point of contact. If you add, then you are getting the one chord again. It is known as the chord of contact. So this equation, the chord of contact equation, is what? Equation of the chord of contact, we say that it is t equal to 0. Only t equal to 0. Equation of the tangent, and it is equal to 0. Combined equation of the pair of tangents. If you are interested to find out the pair of PA and PB equations simultaneously, then you have to write S1 equal to t square. That means S1 equal to t square is the S is the original conic, H1 is the value of the conic at the point x1 y1, and t square is the tangent. From that point, if you draw the tangents, then it will happen. Now coming to the family of the circles. So here we are discussing the three types of family. So first of all, you have the two circles. One is the family S1, another is the family S2, and what we observe that the equation of the family of the circle which passes through the point of intersection of these two circles. So this is the first circle, this is second circle. They are intersecting at the point A and B. Now how many circle we can draw? Infinite number of circle can we draw, those circle passing through the point A and B. So now the equation of this family we can write as S1 plus lambda times of S2. But remember here, this equation cannot generate S2, because whatever the value of lambda you can choose, either if you choose 0, then the S2 is vanish. So whatever the value of lambda you can take, you cannot find the S2 as the member of this family. To accept S2, all the member you are getting. So here we should write lambda cannot be equal to lambda cannot be equal to minus 1. Why it is not minus 1? If lambda cannot be equal to minus 1, because if you subtract the quadratic equation which has the coefficient 1 and 1, x and y, and again another quadratic equation has the same coefficient 1 and 1, then the quadratic terms cancelled out. As a result, you are getting the linear terms, and your equation will become a circle. It will become a it will become a straight line. So that is the problem. Lambda cannot be equal to minus 1. So more general way, if you want to get all the families of these intersections, then more general way you should write mu into S1 plus lambda into S2. So now what will happen? From here you can find the member. If mu is 0, you can find lambda is non-zero, then you can find the family S2 also. Now equation of the family of the circle passing through the point of intersection of the circle and the line. So suppose this is a circle, this is line. Now if you are going to intersect it, you have the interest to find the equation of the circle who is passing through this point of intersection. Then how can we find S plus lambda times of L? S plus lambda times of L. This will form. Conversely, if whether you are getting S plus lambda L equal to 0, then you have to understand that one circle is there, one line is there, and they are intersecting, and all the families members passing through their point of intersections. Another type of family is there, that equation of a family of circle passing through the two given points is the equation of the family of the circle passing through two given points. Only two given point is given on the circle. There are one point, suppose x1 y1, another point is b, x2 y2, and they are asking if the only 2 points coordinate you are known, then how can we find the equation of the circle? So first of all, we consider it is x minus x1 and x minus x2 plus y minus y1 and then y minus y2. But here they never said they are the end point of the diameter. Okay, now so we take this one. equation of the family of the circle passing through the given point these and this. So first of all, it represents a circle plus lambda times of, you have to take x1 y1 xy and 1, x1 y1 1, x2 y2 1 is equal to 0. So now this combined equation will be the family of all the members which passing through the point of intersection of the circle with the lines. Now the now the in details proof is there. When I teach you the topic wise concept, then in that time every proof I will write in my videos, in my notes also you will get. But now since here our target is only complete the concept, definitions and formula, that means only the formula parts we are going to complete in short, then it will do like that. Now next one is what, equation of the circle. You have to find equation of the circle touching a line at its fixed point x1 y1. So a line has the fixed point x1 y1 and the circle touching at that point x1 y1, then what will be the equation of the circle? So now first of all we take any point on the circle. So what will happen, you are getting here the point circle x minus x1 whole square, y minus y1 whole square, equation of the family of circle touching a line at its fixed point. So suppose this is a line and circle is touching like that at the point x1 y1, okay now. So now you are taking what, now this x1 y1 we consider as the center, okay now. So now first of all we form the point form where the radius is 0. So it will be x minus x1 whole square plus y minus y1 whole square plus lambda times of L. L is the straight line, okay now. So now till now it is okay, no problem, because we don't need any proof, any more explanation. In the theory classes we will do there. Equation of a circle circumscribing a triangle whose the length of 3 sides are given. That means suppose that it is a circle, inside there is a triangle and its 3 sides are given to you, then you can easily find the equation of the circle. So how can we do that? So we have the relation that family of circle will be L1 L2 plus lambda times of L2 L3 plus mu times of L3 A1. So, and here we know that in case of a circle the coefficient of x square is equal to the coefficient of y square, and both coefficients are equal. That is the first part. Okay. Coefficient xy is g, coefficient of h is coefficient of xy, that is equal to h should be 0. So now after applying this condition we are able to find the lambda mu, we will able to find the lambda and mu, then we will get the equation of the circle. Now how many tangents are there? How many tangents we have? So one type of tangents are there. When you have the tangent, then your common tangents having the circle on the same side. So this is called the DCT, that is direct common tangent. Another type of tangent is there. Suppose you are taking tangent and the tangents circle are on the opposite side of the straight line or the tangent, then it is known as the transverse common tangent, TCT, and this one is the DCT, direct common tangent. Now in different situations appears when you can also count the number of circles or number of tangents, you can also count. Suppose here is the one circle, here is another circle, that means the distance between their center is more than the sum of their radius. So we can say that C1 and C2 is greater than R1 plus R2. So if this is happen, then the two circle will not intersect. If they will not intersect, they are separately, then we can draw tangent 1, tangent 2, then here one tangent, another tangent is here. So we can say that two direct tangent, common tangent, and two transverse common tangent we can draw. So there are 4 tangents when they are separated. Now two circle comes closer, then what will happen, we can say that R1 plus R2 is nothing but C1 plus C2. So here you notice that one tangent, second tangent, and third tangent. Out of three tangents, 2 tangents are the direct common tangents and one tangent is the not a direct common, transverse common tangent. So therefore we have the 3 tangents. Now it may happen that one bigger circle is there, one smaller circle is there, just touching the bigger circle. So at the point of their contact we can draw the one tangent. At the point of contact we can draw the one tangent. So in this situation, two circle when touches each other internally, externally. So when they touches externally, what will happen? When the two circle touches, these cases we discuss. Okay, when the two circle touches externally, so this will happen that like that, like that. So here you are getting one tangent, here another tangent, here another tangent. So three tangents you are getting, two towards direct common tangent and one is the transverse common tangents. Now next is what will happen if your circle is like just inside the circle. Your circle is inside the circle, and what we notice that inside the circle, and you have to find how many tangents are there. So first of all, if it is happened, then the two circle intersect each other. Two circle intersect each other. Okay, internally touch the number. Okay, now we first discuss this point 4. If the two circle internally touch to each other, then only one tangent is present. Now it may happen that C1 C2 distance between two center is say R1 R2 modulus. That means the two circle touch each other internally and the number of tangent is 1. But if one circle is lies inside the another circle, then the number of tangent is 0. That means you say that if one circle is here, another circle is here, then the number of tangents we get 0. Okay, now so I think I will discuss all the cases. Now coming to the point number 26, direct common tangent is there. That means if you have one circle is here, another circle is here, and you are going to interested to calculate this length. This is called the length of the direct common tangent. If it is P point, it is Q point, and you are interested in DCT length, then you can apply this formula D square minus R1 minus R2 square. So now what is D? D is the distance between the center. You are taking this D, distance between the center, minus R1 minus R2 whole square. Now it will happen that if you are going to take the length of the, if you are going to calculate the length of the internal tangent or transversal tangents or inverse tangent, then how can we find? So it will be like this one. So here one tangent is going on. Okay, now let me use the another tool. So this is my circle, now one is here. These things I want to calculate. What is the length of this PQ? Okay, now so this is length of the transverse common tangent, and here we get the result L is equal to D square minus R1 minus R2, R1 plus R2 whole square. Okay, now so that is the TCT, transverse common tangent. So now in case of a transverse common tangent, you notice that in case of the transverse common tangent, the length is what? Length of inverse common tangent or transverse common tangent. The formula is this one, D square minus R1 plus R2 whole square. But in case of a length of, or you can say that external inverse, and here the external you can say, or it is known as, first one is known as transverse. Okay, now so this is our transverse, length of the transverse common tangent. So length of the direct common tangent, if you are going to calculate, the formula will be this one. For direct common tangent, D square is there minus R1 minus R2 is there. So you know that this quantity is always lesser than this one. So what we say that this value, that means direct common tangent, the length is always transverse common tangent in the given restrictions. Okay. Next important part is what I say here, wait, erase this part, paste, copy, cut this part. Okay, now no required. Here also you can copy this, you can cut this, no problem. This one also we can cut. Take the figure like that, and using the lasso tool we can cut it, delete, we can delete. Okay, now here only few points are there, the very easily uh, very few points are there, only less number of points are there, so we can easily explain them. So radical axis of the two circle is locus of the point whose power with respect to the other circle are equal. What does it actually mean? So two circle is there, one is s1 is equal to 0, other is s2 equal to 0, and they say that the radial axis is the locus of the point whose power with respect to the whose powers with respect to the two circles are equal, whose powers with respect to the two circles are equal. Now how can we draw this figure? How can we draw this figure? Locus of all the points, radial axis of two circles, radial, wait, हेलो, ओके ओके भाई, हाँ हाँ, ठीक ठीक है, अच्छा. Okay, now what we discuss the radial axis. So radial axis you can say like that, if you have the two circles, now for the first circles I am taking radial axis, that means you have to take the tangent, length of the tangent, this one. If I say this point is P, this point is A, so square of this length of the tangent is known as the power of the point P with respect to the circle. So this point, and you are taking another point, another circle is here, and you are drawing the tangents here at the point B, and if you are getting PA square equal to PB square, then you can say that the locus of the point P is called the radial axis. Locus of the point P is called the radial axis, and radial axis you are getting like that. Radial axis you are getting like that. This will be the radial axis. From here, if you are taking the two tangents to the curve, and you notice that their length will be the equal, square of their length should be the equal. So power of a point is nothing but the square of the length of the tangents, and if it is happened for the two circles, then we say that the locus of this point is known as the radial axis, and generally we are getting the straight line, radial axis. How to find it? Now if it is the s1 and if it is s2, now simply doing s1 minus s2 equal to 0. If you subtract the one curve from the other in their general form or in their standard form, then you can get the radial axis, then you get the equation of the radial axis. Few points are there on the radial axis which are very important for the exam point of views. If two circle intersect, then the radial axis is the common chord of two circles. Suppose this is the two circle where they intersect, then the radial axis will be this one, their common chord will be the radial axis. And if two circle touches each other, then the radial axis is the common tangent of the two circle at the common point of contact. So if they are touching each other, suppose in this way or internally externally, then this tangent will be the radial axis. Radial axis need not always pass through the midpoint of the line joining the center of the circles. So this is, suppose this one and this one, so this point need not necessarily be midpoint. This point did not, M cannot be the, not necessarily the midpoint. Okay, now it depends on the radius of the circle where the M will lie, so not necessarily passing through the midpoint of the line joining the center of the circles. Radial axis bisect the common tangents. Radial axis bisect the common tangent between the two circles. Radial axis bisects a common tangents between the two circles. Okay, radial axis bisect the common tangents between the two circles. The diagram will be look like that. Suppose this is one circle, this is another circle, and this will be the common tangent, and your radial axis will be here. Okay, now this is the locus of the P point. Then you notice that this point will be the middle point of these and these. So radial axis will bisect the common tangent. It will be the direct common tangent or transverse common tangent, it does not matter. Radial axis bisect the common tangents between the two circles. Pair of circles which do not have any radial axis. So suppose you are taking the concentric circle, the circle which are concentric circle. So in case of a concentric circle, you notice that there is no radial axis. There is no radial axis. So this is the definition of concentric circle. Again, if two or more circle are there which don't have any radial axis, okay, now then we say that they are the concentric circle. So pair of circle which do not have the radial axis are the concentric. Now, if one circle contained in the another circle but not the concentric, then what will happen? When the radial axis passes outside to both the circle, if one circle is contained in another circle but not concentric circle, they are not the concentric circle, when radial axis passes outside to both the circles, so radial axis will passes outside of the circle. Okay, now so these are the few points we discussed regarding the radial axis. Now coming to the radial center. The common point of intersection of the radial axis is of three circles taken two at a time. So first of all you have to draw the three circles, 1, suppose 2 and 3 and 3. So now these and this has the radial axis like this one, these two has the radial axis this one, these two has the radial axis this one. The point of intersection of the radial axis taken two at a time, then we get this point of intersection. This is known as the radial center, not the radial center, that is radical center. Okay, now, and here we have radical axis. So point of intersection of the radical axis is known as the radical center. Okay, now you can find also the conditions, the condition for the radical center. So in this, using this determinant, you can also find three circles are there. So three circle having the three equations, and you are using this concept in determinant, and you can find out. Now two circles are said to be orthogonal if they intersect. Whenever they intersect, they will intersect at 90 degree. Now what will be the condition of this? 2 into G1 plus G2, G1 G2 plus F1 F2. So now take the constant G1 and the constant G2, multiply them. Similarly F1 F2, multiply them. 2 times of G1 G2 plus F1 F2 is equal to C1 plus C2. This condition is known as condition of orthogonality. So now if a circle is orthogonal to remaining three circles, okay, now if one circle is there which is orthogonal to the remaining three circles, then what will be the conditions? Then how can we find the equation of that circle which is perpendicular to, when they intersect each other, they are perpendicular to each other. So now again using the condition of orthogonality 3 times you can find out. Now one more thing is there which is not in your syllabus, that is known as the pole and polar. You know about pole and polar. So what is pole and polar actually is, suppose if through a point in the plane, of the circle there be drawn any straight line to meet the circle at the 2 point Q and R. So suppose I am taking one circle here, I am taking this one, and what they say, if through a point P in the plane of the circle there be drawn any straight line to meet the circle at the point Q and R. So through this point P I am taking the intersect at the point Q and R, at the point Q and R. So this point is Q, this point I am considering as R. So through the point P I am drawing any line which intersect my circle at the 2 points. Now what will happen after that? The locus of the point of intersection of the tangents at the point Q and R. Now at the point Q and at the point R you should draw the tangents. So now these will be the tangents at the point Q, these will be the tangents at the point P, and they will be intersect here. Okay now. So in this way, from the point P you should draw the tangent, draw the secant, and they intersect here. From here you have to draw the tangents, and again now where the tangent intersect you have to notice that this is one tangent, this is another tangent, they will intersect here. So in this way, if you join all these points, you are actually getting a straight line. This line is known as the polar of the point P. So polar of the point P, is it clear now? So pole is the point P and polar is the line with respect to the point P. So what is their definition? Through this point P we draw draw so many line that we want. They intersect the circle at 2 distinct point, and every distinct point we should draw the tangents. Now these tangents will intersect at one point. Now if we join this point of intersection of the tangents at every time, then we will get a line. This line is known as the polar of the point P with respect to the given circle. So how can we find the polar of the point P? Now simply you have to calculate t is equal to 0. This will be the polar of the point P. And again, if x1 y1 is lies on the circle, so if you have the point here x1 and y1, and you are going to calculate the tangent at the point here, so tangent and the polar and the chord of contacts all are the same things here. Okay now, so hope guys, in a short I am trying to explain most important formulas, but not in great details, because when I teach you this topic I will describe each and everything. I will give the proof also. Okay now, so please don't forget to subscribe my channel and press the bell icon, so that you will be every time updated with the Maths Academy. I am Nur sir, I am saying bye, have a nice day. In the next video we will meet, and go through my website mathsacademy.org.in and download everything that you want to download. Bye, have a nice day.